Okay, so good day everyone. Today we're going to solve some problems that is related to linear differential equations. So these are the first two problems that we are going to solve for today. Let's find the solution of each of the following equations which satisfies the given conditions. For the first problem, it would be y double prime plus 4y prime plus 5y is equal to 20e to the x, wherein y is equal to y prime is equal to 0 when x is equal to 0. For the second problem, it would be y double prime plus 4y prime plus 4y is equal to 8x minus 10, wherein y is equal to 2, y prime is equal to 0 when x is equal to 0. So first, let us solve this equation. So it is y double prime plus 4y prime plus 5y is equal to 20 e to the x. So what would be the first step in solving this kind of problem? Let's first convert this one into its quadratic form. So let's say let y double prime be equal to m squared, for example. So it would be m squared plus 4m plus 5 is equal to 0. So let's use the quadratic formula to find its roots. So it would be a is equal to 1, b is equal to 4, and c is equal to 5. So using the quadratic formula, it would be m is equal to negative 4 plus minus b squared, which is 16, minus 4ac, which is 4 times a, which is 1, times 5, which is c, which is equal to 20, over to a. Since a is 1, so it will be just 2 here. So this becomes negative 4 plus minus square root of negative 4 all over 2, which is also equal to negative 4 plus minus 2i over 2. So we have now this plus minus, so it means that there are two roots here and it is both imaginary. So for our m1 is equivalent to negative 4 plus 2i over 2. Or it is also equivalent to negative 2 plus I. For m2, or m2 is equivalent to negative 4 minus 2i over 2, or equivalent to negative 2 plus minus I. So we can see that our two roots have a real root and an imaginary root. So this falls under case 3. So because it is of case 3, so the format of its yc would be yc is equal to e to the alpha x times cy cosine beta x plus c2 sine beta x, where alpha is the real root and beta is the imaginary root. So the yc for the equation becomes yc is equal to e, and then alpha which is the real root, would have the value of negative 2. So negative 2x times c1 cosine, our beta is the imaginary root, and our imaginary root is I, which has a coefficient of 1. So cosine beta is what? So beta is equal to 1. So it would be cosine x plus c2 sine x. So this is the formula of our yc. Now let's go to have our yc over here now. So now let's solve for yt. Now how do we solve for yt? So let's go back to this equation. y double prime rather, plus 4y prime plus 5y is equal to 20 e to the x. So let's look at this 20 e to the x. The format of this would be the format of your yt. So 20 e to the x is also of the form a e to the x. So this would be the form of our yt. So our yt is now a e to the x. Now let's find yt prime, which is still a e to the x. The y double prime t is, well, still a e to the x. So now let's substitute. So y prime plus 4 y double prime rather plus 4y prime plus 5y is equal to, let's substitute it. So y double prime, yt double prime, 4yt, 5yt. Now let's substitute the values. Y double prime t is a e to the x plus 4 times y prime, yt prime is still a e to the x plus 5 times yt, which is still a e to the x. So now we have a e to the x plus 4a e to the x plus 5a e to the x, and we will going to equate it to our fx, which is 20 e to the x. So on the left side we have then a e to the x is equal to 20 e to the x. So from here we could conclude that a is equal to 2. So we have now the value of a. Now we're going to substitute it. Okay, now so we have found the value of a is 2. So now we're going to combine a's, yc and yp. So the equation would be y is equal to yc plus yp. Now remember that we solved both of this earlier. Yc is equal to e to the negative 2x times c1 cosine x plus c2 sin x. Now we have to solve for the first equation, this one. Now let's go to the next equation. Y double prime plus 4y prime plus 4y is equal to 8x minus 10. Conditions are when y is equal to 2, y prime is equal to 0, when x is equal to 0. So again, let's write the equation. So it's y double prime plus 4y prime plus 4y is equal to 8x minus 10. So first let's make it into quadratic form. So it becomes m squared plus 4m plus 4 is equal to 0. Now let's find the roots. So m plus 2 times m plus 2 is equal to 0. So you can see that they are identical. So m is equal to negative 2. So since we have two real identical roots, it falls under case 2. So the form of the YC of case 2 is YC is equal to C1 E M1 X plus C2 X E M2 X. So we have now this form of YC. So now let's solve for YT. So this is the format of our YT. So YT is equal to AX, it's 8AX, minus B, this stands for 10. Now let's solve for YT prime and YT double prime. So YT prime is equal to 8, while YT double prime is equal to 0. So now we have the values of YT prime and YT double prime. So now let's substitute. So we have now Y prime plus Y double prime plus 4y prime plus 4y is equal to YT prime, as we have noted, is equal to 0 plus 4 times YT prime, which is 8, plus 4 times YT, and YT, as we have solved earlier, is AX minus B. So now we have 4A plus 4 times the quantity AX minus B is equal to, let's equate it to the original, which is 8x minus 10. So we have now 4A plus 4AX minus 4B is equal to 8x minus 10. So let's combine like terms. So 4AX plus 4A minus 4B is equal to 8x minus 10. So both of these have x's and both of these parts are constants. So now it becomes 4A is equal to 8. We have omitted x in this case. So A is now equal to 2. On the other hand, 4A minus 4B is equal to negative 10. These were from the constants. So now let's substitute the value of A. So now it becomes 4 times 2 minus 4B is equal to negative 10. So 8 minus 4B is equal to negative 10. So 8 plus 10 is equal to 4B. So do the math. So we have now B is equal to 9 over 2. So now we have the values for both A and b. Now we will substitute these values to the equation. So the equation for y, as we have said earlier, is y is equal to yc plus yp. We have solved yc earlier, which is c1 e to the m sub 1x plus c2 x e to the m sub 2 x. We have also solved yp earlier, and yp, from yp we have solved values of a, which is, so the value of a, which is 2, and we have solved value of b, which is 9/2. So now we have y is equal to c1 e m sub 1 x plus c2 x e m sub 2x plus ax minus b. So substituting these values that we have found early on, we have y is equal to c1 e to the negative 2x plus c2 x e to the negative 2x plus 2x minus 9/2. So this would be our working equation. Now we will find the values of c1 and c2. So earlier we have been given certain conditions in which y is equal to 2, y prime is equal to 0, when x is equal to 0. Now we are going to use these conditions to find the values of c1 and c2. Now first let's solve for the value of c1. So let's substitute the value of y. So we have 2 is equal to c1 times e to the 0 plus c2 times 0 times e to the 0 plus 2 times 0 minus 9/2. So we have 2 is equal to c1 minus 9/2. So c1 is equal to 4 plus 9/2, which is equal to 13/2. So the value for c1 is 13/2. Now with that, let's solve for the value of c2. Now how do you solve for the value of c2? So again, let's write the equation. Y is equal to c1 e to the negative 2x plus c2 x e to the negative 2x plus 2x minus 9/2. Now we have gotten the value of 13/2 for c1 earlier, so let's substitute it. So y is equal to 13/2 e to the negative 2x plus c2 x e to the negative 2x plus 2x minus 9/2. Now let's get y prime. Y prime is equal to negative 2 times 13/2 e negative 2x plus c2 e to the negative 2x minus 2 c2 x e to the negative 2x plus 2. So now let's substitute the value of y prime to 0 when x is equal to 0. So 0 is equal to, this gets cancelled out, so it becomes negative 13 e negative 2 to the negative 2x plus c2 e to the negative 2x minus 2 c2 x e to the negative 2x plus 2. So now it becomes negative 13 e to the 0 plus c2 e to the 0 minus 0 plus 2. This was 0 because it was x is equal to 0. Remember that. So now we have the value 13 plus c2 plus 2 is equal to 0. So c2 in short is equal to 13 minus 2. So c2 is 11. So we have now the value of c2. Earlier we solved that c1 is equal to 13 over 2. So what would be the final equation? So the final equation would be y is equal to 13 over 2 e to the negative 2x plus 11x e to the negative 2x plus 2x minus 9 over 2. So this is our final equation and the solution, and also a general solution for the equation. Now, people, ladies and gentlemen, remember that we have solved the previous two equations using the method of undetermined coefficients. So the previous two equations were solved using the method of undetermined coefficient.